Albert Einstein is one of the most famous scientists of all time. His theory of relativity has been a source of fascination for generations of scientists and laypeople alike. But what exactly is Einstein's theory of relativity? How does it work? This article will provide a simple explanation of Einstein's theory of relativity. Einstein's theory of relativity states that the laws of physics are the same for all observers in all frames of reference, regardless of their relative motion. This means that no matter how you look at an event, the outcome will be the same. In other words, the speed of light is constant no matter how fast you are moving. One of the most famous implications of Einstein's theory of relativity is the notion of time dilation. Time dilation states that time passes slower for an observer who is moving at a high speed relative to another observer. This means that if one observer is moving at nearly the speed of light, their clock will seem to run slower than the clock of the other observer. The theory of relativity also states that mass and energy are equivalent, as expressed by the famous equation E equals mc2. This means that the energy contained in a given mass is proportional to the square of the speed of light. This implies that large amounts of energy can be released from small amounts of mass, as is seen in nuclear reactions. Finally, the theory of relativity also states that gravity is a result of the curvature of spacetime. This means that objects with a large mass, such as stars and planets, cause spacetime to curve around them. This is known as gravity, and it is responsible for the orbits of planets as well as other phenomena, such as the bending of light around massive objects. In summary, Einstein's theory of relativity is one of the most important scientific discoveries of all time. It states that the laws of physics are the same for all observers in all frames of reference, regardless of their relative motion. Time dilation means that time passes slower for an observer who is moving at a high speed relative to another observer. The theory also states that mass and energy are equivalent, and that gravity is a result of the curvature of spacetime.